Well, hello everybody. Welcome to another Friday CCOM seminar. That's not my It's not you. Just before we begin, just for folks that are possibly interested in kickball, if folks could meet outside just after a seminar, and we'll kind of get a head count, and hopefully we'll have an inaugural game today. Today's seminar speaker is our very own Kurt Schwehr. He's going to be talking about ERMA, the Environmental Response Management application that was used to help with the response to the Deepwater Horizon. Kurt started working on ERMA in 2006 with Rob Braswell over in Complex Systems in Warsaw. And he's also worked on similar systems at NASA related to Mars missions, looking at situational awareness and workflow tools that are web-based, as well as writing a custom GIS software in the 1990s to also help with Mars spacecraft missions. And for ERMA, he's really been involved with the system architecture and design and configuration of the software, as well as the tracking of ships and personnel and buoys, and also implementing water level tides, bathymetry, and backscatter data to be present in ERMA. So, great.
All right, thanks. Just before we get started, I have not actually been down for this spill. When I was on this response, I was actually in Dover most of the time, which is really not very close to Mississippi and Louisiana and Florida. What you're going to see today is mostly based on work that I did remotely on the computers. What you saw up here as you came in on these photographs, I stole those from other people. I didn't take a single one of those pictures. And this is just to give you guys a flavor of what it is out there that you don't really know what's going on. It's kind of crazy and wild, and it's hard to get a sense of things. Even listening to people who are out there, having a sense of what's going on is kind of challenging. So I'm going to give you guys a history of sort of where ERMA came from and how it's been used so far and where it might be going. I want to start off by showing you sort of sometimes history comes back and bites you. This up here on the top right is the picture of a board game that BP put out in the 70s called Oil Strike. And apparently one of the features it had is you could draw a card and you have an oil spill. So unfortunately, not so happy. Oops, wrong way. This is something that, thanks to John Kelly, I just found out about yesterday, that actually ERMA and GeoPlatform, and you're going to see GeoPlatform is a separate project, but it uses ERMA for at least the Deepwater Horizon. Just won an award from a magazine called the Government Computing Network, I think. So we're getting acknowledged for some of the work we've done with the spillover response, which is very nice. And most important to remember up here is that I might be presenting this, but a lot of people have put a lot of time and energy and paid and unpaid time in that. So sometimes people have been donating a lot of stuff to us, and we really appreciate that. I want to call out 3 people that are up here, specifically Rob Braswell helped create the initial version with Michelle Jacoby and I. The 3 of us spent a lot of time just trying to figure out what it was we were trying to accomplish. And Aaron Rassicott is a contractor in Seattle who I've never actually met, but he and I have pulled all-nighters on this, trying to make sure that everything was working for the spill response folks down in the Gulf. Aaron has put in more hours than I think is humanly possible in the last 4 months on this. And I'm sure I'm missing people in here from various places at UNH that have put in huge amounts of time. There's just so many folks involved in this trying to make it happen. And it's important to know when people have biases or not, and you can judge this on your own. I actually have taken money from BP in the past, so you can judge my bias based on that. I did some work for my PhD with them, and I'll show you some pictures that come from an Exxon event, and I did actually get a gratis training out of Exxon for a little while. All right, so let's go back to 2006 and give you a little bit of history. Talking to some managers for spill response, trying to figure out how they do stuff. I asked the question, how do you track what's going on, to this guy who's an incident commander? And he was very happy to answer me. And the spill coordinator responded with, we call him every 15 to 30 minutes on the radio and say, hey, where are you? And then we write down the latitude and longitude, and we're good. It's great. Works wonderful. You know. That's my response. That's great when you have one response vehicle, maybe 2, 3, 4. Deepwater Horizon, they sent me a list of 3,000 ships. I'm not going to try and call 3,000 people in 15 minutes and get their lat longs, write them down right, and get them up on a map. It's just not going to work. So let's think about the typical situation that people train for with a spill response. Typically, it's a ship that has some sort of problem, it dumps some oil in the water, and you go and you deal with it. You try to mitigate it as best you can. We have a database full of these. MISSILE is the Coast Guard system that's supposed to be your incident response tracking system. It's protected, so I have actually never seen the real front screen of it. There's a little red light over it when it's running. But out of it comes a list of incidents that they track, and these are all spills or collisions when somebody runs into something, or two ships run into each other for a collision, or fires on ships. These are things that dump oil and other materials in the water. You've got to send out an incident team for. So we've got a pretty good handle that they occur fairly often. Every so often we get a big one. This is the Exxon Valdez. Some of you might remember this from 1989. It was a huge event. And it really was a huge amount of oil in the Prince William Sound, but it was a contained environment. So you'll see later on that this isn't always the case. A little bit closer to home, Alaska, for most of us, is far away. The Costco Busan in San Francisco Bay actually didn't dump that much bunker oil in the water, but it did a lot of damage. It was big on the news. This is just a ship bumping into a bridge. It really wasn't that major of an event. But here's a boat with some people on it to give you a sense of the scale of what can happen when a large ship runs into a non-moving object. The neat thing that's been happening in the last 10 years is we now have technologies that track ships. So we can get data about who's going where, why, and when things go wrong, we can go back and see what happened. So here you can see in blue is the tug Revolution that was alongside the Costco Busan taking it out of the San Francisco Bay here. They headed out towards the Bay Bridge. They're supposed to go over here, and they went over where there's a bridge abutment and clipped it. And then they went off to a holding spot. The Coast Guard sent them down here while they were leaking oil, and they sent the tug back home to go away. So now we can see what's going on with that incident. While it's happening, after the fact, we can analyze what's going on. We can think about the future. To bring it home, this is off of Boston in February 2008. At 3 a.m. in the morning, an LNG ship full of natural gas, this is liquid natural gas, lost all power. And we were very lucky that weekend or day when that happened. The winds and currents were offshore. We got really lucky that ship got pushed away. They had time to get the ship restored. It took them quite a few hours to get the engines running again. If that had gone the other direction, it would have been into Boston, and we would have had a pretty scary event with an uncontrolled LNG ship, basically a giant floating bomb coming around. The cool thing here is when the ship had the incident, we had a crew that did something that very few crews had done to date. They actually marked their ship as not under command, so that hopefully people watching on their ship tracking devices would actually see that this ship didn't know where it was going, and it was under control of winds and waves and not the actual ship. So basically, with that kind of information, we can ask the question of, can we evaluate these risks and can we mitigate them? And mariners have had tools to do this for a long time. This is the source data diagram for a chart. It tells you something about when the chart was done. You can see that some of the chart came from 1842 all the way up through 2002. And it gives a mariner a way to sort of evaluate what's going on and do a risk assessment of when they're going through an area, about the quality of the data that they're using and whether or not they want to transit a particular direction. So when people are looking where to go, like say Shep here, when they're working with their charts, they can figure out what kind of risks they're willing to take with their ship. From the shore side, we can start looking at how many ships are going in what areas, and do we have a risk of collisions because there's too many ships near each other? Are they going near objects that are dangerous? Are they coming into contact with, say, whales or things that they might hit? And you can start doing that risk analysis. We can go look in detail. This is Norfolk, Virginia. And we can start looking at types of ships, how deep their draft is, and what they might be doing. So if we go look into part of the harbor, you can see here individual ship tracks. You can do, say, things like cluster analysis and figure out what kind of ships are using this waterway. There's an area just north of here where all the ships with explosives on them are supposed to go anchor. And the folks without explosives are supposed to anchor over here. So you can start looking at the risks of having those ships in those areas. Are people following the rules and what's going on? And match that up with what's the intended use for the area and how things are going. In this area, we actually have ships that are brushing the bottom. You can see in multi-beam sonar surveys of the area that the people are actually going through the mud. So we have clearances of negative centimeters below between the ship and the bottom. That's all great until there's an old anchor or something in the way. And the idea then is you can build a system that's going to watch the environment and do risk analysis. So here's some figures from Brian Calder that look at this and look at the risk of grounding and having a ship incident where you have to have a response sent out. And then you can try to mitigate that. You can tell a ship, I'm sorry, you can't come in at this tidal regime because there's just not enough water between you and the bottom for our particular harbor. And you might also be able to look at the kind of ship and say, well, you know what, your ship doesn't have any real risk. If you run aground, you're going to be stuck for 2 hours, then we'll get you off. Doesn't really matter. Things like this happen in the Mississippi River where they have groundings all the time. They just have to get someone out there, pull them off, and the barges just keep going. The real message here is that no matter how hard you work to reduce those, you still will have bad things that happen. You don't want them to happen as often, but no matter what we do, we're still going to have to go out there and deal with problems when they happen. And we do a lot to be prepared. Here's one of our students going through fire safety training, getting ready to put out a fire. So we have to think about what's going to happen when things go wrong, and can we deal with that? So how are we going to respond as not just a person, but as a whole country when something goes wrong? You send out the Coast Guard, and hopefully they're going to get out there and make your day go better. This is one of our new boats. This goes 40 knots. So if you need somebody out there fast, we've got some really great ships, but we need to back them up with information that gets them to the right spot. We had an incident where the Coast Guard, due to old satellites, sent an incident response to the Gulf when somebody was off of Virginia having troubles because the satellite couldn't tell Atlantic versus Gulf. We need to improve our systems so that we can get these hardworking folks on the water out to the right spot with the right gear. In the past, and still, the most common thing that you're going to see is a PDF and a big poster. So look around the walls here and see these maps, and think about how old they are. The minute you print out a map, it's stuck in time, and if you want to go figure out where something is, you're going to have to look at the size and calculate where it is and say, okay, I need to get my ship over here. How am I going to do that? You can't put that paper and shove it into your chart plotter on your ship and get yourself someplace. You're going to have to go integrate it into your map system by hand. You need to start thinking about how to take these things, and they get fancier and they give you contours, but how can we get that into an electronic form? And I'd like to show you guys this one, which illustrates the time feature. And when oil spills are just happening, those first few hours, if it's a ship that's just leaking a bit of oil, if you can catch that oil quickly, it's not going to get into your marshes and your rocks and whatnot and be hard to clean. You can put a boom around it and get it contained. This was an overflight on the 28th at 1800. This map came out the next day on the 29th, and it probably didn't get out to people for another maybe 6-8 hours in the field. So all that time went by. This oil is sitting on water. It's not going to hang out there. There's wind, there's waves, there's currents. It's going to go someplace. And so if you've got yesterday's map of where the oil was, you have no idea where the oil is today. So the solution needs to be that we need to provide some way to assist in those first few hours. That was the goal of ERMA, or in its early instances it was called Portsmouth Response, was to create a technique where we could go out and figure out how to give everybody a head start. You may still want to make those paper plots, but you need that right now information. You've just gotten off a plane, it dropped you in a boat, you got to go get some oil. What can you have in your hands that's going to make your day go better? This is what the Coast Guard has. These are some of the few public release pictures that I've been able to get of some of their systems. This is them tracking ships, and this is the Gulf of Mexico. It's a giant yellow and blue blob of ships. There's probably 2,000 ships in that blob, and so the Roland ship right here is somewhere between here and over here. That's a pretty big area. It's the size of Texas. So tools like this are a good first cut, but we need to do a lot better. There's web tools that are starting to get going. They can only be used by a few people. They're all restricted. And they've got a bunch of green dots that slowly crawl around on the screen. We talked to the EPA in the beginning of this. They came and visited with the Coastal Response Research Center and a bunch of researchers working on ERMA and other response-related stuff. And they gave us a tour of their website. They've been doing emergency response for a long time. They've been trying to modernize. And they have a really great tracking system for all the chemicals and whatnot. And some of you might remember in Danvers, in I think 2006, there was a large explosion that actually registered on all the seismometers around here. A chemical plant blew up. It was a really big event. They had a lot of response work to do. So these are the pictures from it in their actual database. They've got some summary stuff. You can download documents. Lots of pictures that the EPA staff took as they were out working on the scene. You'll notice there's no map. There's no incident site map that you can go zoom into and see which part of the town was affected. It's just not a mapping tool. It's a really great website, but it doesn't have that spatial GIS component that's so important to response. So we'd like to take this ERMA concept and basically provide them that quick look environment. And this actually came out of some of the GIS ARC users who are in these responses. They show up with their ArcGIS and they have no data to feed it. They've never been to this part of the country. They've never trained over here. Or there's just too much going on and they have got users who don't know how to use ARC, but they're trying to manage the teams. They actually asked for an interface that was a little bit better than ArcIMS with a little bit more scrolling Google Maps kind of feel, where people could get a quick look at data, maybe not do as much analysis, but get that, get people moving, track what's going on, and keep that sort of common operational picture that people like to have, or COP, that keeps you abreast of what's going on in the environment. So we came up with a scheme of trying to be able to get data to and from ships, get it back to an ERMA data center, and then start integrating with other people. And so I show up here Now Coast, which is actually started off upstairs and I think now has computers in Silver Spring and here. And then integrate with tools like the VisLab's Colin Ware's FlowVis 2D and be able to start bringing those data and visualizations through the system and get them out to the people in the field. So the idea is you want to take data from all of your different sources, federal through local, get it into some big database, get it out through some interfaces, and get it out to the people who need it. So through some web interface, you want people who use ArcGIS to grab that same data. You don't want them searching all over the web to try and find things. You want them to be able to get those models of where oil's going in the environment. You want people who just need a web interface just to go look at a map, be able to do that. And if someone, say, is using something like Google Earth or NASA Whirlwind, you want to be able to just get data to all those places easily and flexibly. And the ArcGIS tools just weren't doing it for NOAA and the other responders. So what we did is we took a step back and said, what are the requirements and what do we need to do? And as a result, some of the commercial tools just weren't really up to the task. They weren't flexible enough. They're really powerful. They do great work. But we needed the open source and open protocols strategy to go in and to be able to control things ourselves. There's a lot of really expensive, complicated tools for oil spill response. And if you go to any particular company, you'll find they've got 4 or 5 of them, spending $50,000 or $100,000 on some of these things, for 1 or 2 copies. That means when a small response group joins in, they've got to go buy that same software, go through a whole purchasing process, and already you're in trouble. The scalability in there, it's doable, but the time scales are just too short with an environmental response to be able to go through procurement and deal with all that kind of stuff. So I want to show you one example of how that can pay off. You may have heard of OpenStreetMap. In this interface, it's people go out with GPSs and they drive around or they walk trails. They put it all into the system and they generate a map. And so it's user-contributed data. It's sort of the crowdsourcing mode. And this is Haiti, Port-au-Prince, right after the big earthquake. And before this, there was almost no mapping data in this area. And these were all volunteers who jumped in and quickly made a map of the area so that first responders could be out there with a real map. The great part about this is, say you're in Portsmouth and a ship hits a bridge. If you want to go to Google and get them to change their map data, it might be quite a while until you find the right person to do it. They get permission to do it. They verify that the bridge is out. Meanwhile, you've had to reroute firefighters who don't have like a Google Maps way to go in and say, I need to get from here to there, but suddenly I'm missing the bridge that I use every day. With OpenStreetMap, we can go in, we can flag that bridge is gone, and the routing tools will get the firemen right to where they need to go. The mapping tools will know they need to take a detour. A side benefit of this, without having some of these big companies in the way, sometimes like ESRI, is we actually went out and hired one of the authors of the tools we use. Chris Schmidt is down in Boston. I've never gotten to meet him, but he's written OpenLayers, which is the interface that drives our maps, and Feature Server, which lets us draw little things on the maps and then save them as GIS layers. He actually was contacted by one of our engineers, and he wrote an interface to one of our databases to allow some management of some of the ship tracking data, because I was just doing too much stuff and didn't have time to get into it. So we went right to the source and we hired one of those guys, and over one weekend he produced a really neat interface for us that we've been using. So we have some flow charts. I figure I'll show that real quick. We have data flowing around. The key thing is that some of the stuff you'll see today is hidden behind an encrypted layer. You can't log in as the public, but the first responders can log in. The idea is that we have some data that's public and some data that's not. So those who are rushing out, so here's Tom rushing out to a pseudo emergency with his buoys.
Just do that.
Thanks. This is a fortuitous slide, because we used this picture of Tom quite a couple years ago, going out with buoys, going out the Cochico as fast as possible, just because that's fun. But Tom ended up spending quite a bit of time out there for the emergency response. So to create a first prototype of this, rather than go out somewhere, a lot of people wanted us to go to the Chesapeake, places where there's a lot of shipping, or even to Boston. We wanted to work someplace where, as UNH, we can really dig into the topic. We don't have to be traveling all the time. We can get out there and get going. So we started with Portsmouth Response. We wanted to work in our backyard and see if we can solve the problem here in our little corner where it's a little bit more constrained. So we created an initial prototype. This is probably February or January of 2007, with basically taking S57 in. This is stuff you've seen with Roland and GeoZooey. Put it into a map interface, create some layers, start integrating stuff from NOAA, and going off to some of the ocean observing groups, and being able to start pulling things together with some of these web technologies that you might have seen on Google Maps and Yahoo Maps. And you can see we're still in the prototype stage here because it says your logo here for we weren't sure who was going to work with us. And then we started looking at what we could possibly do. Can we get bathymetry in there? Well, it's not a 3D interface like GeoZooey or Fledermaus, but you can make a nice geotiff and drop in a geotiff pretty quickly with these tools. We use something called Boodle or GDAL to take geotiffs from tools and just drop them right into an interface where you upload a file, and magically you've now got a new layer with your bathymetry in there. We started working on how to get legends. Legends turned out to be a royal pain, making nice icons for things and making them show up cleanly from ArcGIS or some of the other tools. Ended up being a lot of time. And then things started getting more polished. We had more data layers. You can see that there's now more groups of stuff up here. We've got field photographs going in. We've gotten as much bathymetry as I could find from our archives up there. This will be a little contribution that Val helped me put in there. We're trying to get an interface that's a little bit more usable, got more things going on. Luciano jumped in with some of his backscatter data. We loaded that up one afternoon just to see what would a responder want. It turns out most of the responders don't even know what backscatter is. So we got some educational issues to go on with some of this data, beyond just metadata. I do a lot of ship tracking with AIS. We tried bringing in some of the AIS. So here's a ship, and we're actually starting to track with receivers in Newcastle and Jackson Lamb, which aren't there at the moment because we're now using a Coast Guard receiver. But we're being able to track stuff. Andy McLeod and I went to several vessels, and we actually put AIS transponders or transceivers on ships. This is the Portsmouth Response group. There's some booming gear over here to catch oil. So here's Andy installing an AIS transceiver. And based on that, we now have the vessel CRC Test 1. So we can actually watch a response vessel going through its drills. Turns out he drives up here, he has lunch, and he comes back, and that's a drill. I think we need a little more realism in our drills. And to bring it home, you might recognize this vessel. We put our transceivers on our two vessels. So here's the Cochico heading out. And this gives you the ability to start tracking your vessels and seeing what they're going on with them, whether or not you're on them. You may not have time to be out there watching with binoculars, or if you're the Coast Guard, you're there all the time watching. But it gives people back in the office the ability to see what's going on in the waterway. So here we have a tug. right at the entrance to our harbor, meeting up with a large, I'm not sure which kind of ship that is, but it's a big container ship of some sort, and they're heading up into the harbor. So you can keep track of what's going on in your harbor. And you can also start keeping track of things like cell phones and other stuff like that.
Sorry, Kate.
This is the shoreline classification. So how oil interacts with shorelines is really important to first responders. They want to be able to know where are the areas that the oil is going to get really stuck, that they want to keep it out of first and prioritize. They also want to look at habitats. What animals or plants are in the environment that they need to protect. And combine that with their plans. So before 2001, September, all these plans were public. Since that terrorist attack, the government decided that it's better to keep your response plans hidden. So the problem with this is that first responders don't have access to those until it becomes critical. So you need to, on the fly, be teaching people what they should have been able to know ahead of time. So this interface lets them see, okay, we're planning to deploy boats here with booms. Here's where all the gear is stashed around our harbor. And then, what are the shorelines and how are you going to be managing this stuff in the waterway when you've just gotten off a plane from some other part of the country? There's other things in here like classification zones, how you're going to get in and out of the water, where you're going to deploy booms. All that stuff is encoded into ERMA, so when you show up and turn on the interface, you should be able to get going. One of the things we did with CCOM and co-ops with Carl is we wanted to be able to get more real-time data in there along with the AIS. So here's water level pulled from co-ops. The great part of the internet is you can start gluing things together without having to make any official interfaces. So Carl walked us through how to get data. We have a little icon you click on with a little water level, and magically you'll see that tide station pop up in the interface. So you can right away get a sense of what's going on with the water and the oil and all that at the same time. After building that interface, we weren't sure how this was going to grow. So the next step was to try and add another area and see what we can do. I'm not sure why that Puerto Rico was picked, but they decided that area would be our next good stop. I know that there have been a lot of groundings on the reefs in the last 2 or 3 years they've tried to have a look at. For some reason, ships like to run into reefs. But we tried to grow out into Puerto Rico, and we had some growing pains. Here's some pretty ugly AIS tracks of ships. Figuring out how to get rid of data that you don't want to see when all you care about is down here. We managed to work through some procedures to try and get things a little bit more efficient. We were able to add layers in a lot less time than the first time around. We did pretty well. And the question then became, as you're growing, we're a research institution. We don't want to be the people who are showing up for every response. I'm here to do research. I'm not here to be the one in the field picking up the oil or tracking it all the time. How do we transition this to NOAA, and how do we jump into these drills and get the cross-training between what we know here and come up with and what's going to work in the field? As a part of that, earlier this year we had it's called a Spill of National Significance, or SONS drill. It happened, the headquarters was up in Portland, Maine, and this was in March of 2010. A nice little fancy logo, and they have a nice test thing. They had actual news broadcasts saying this is an exercise, and some guy looking very sad about all the oil in the waterways of the Piscataqua. And so we actually used ERMA with responders, and so they were looking at this interface. Here's just a screen grab that I ran over someone's screen and hit print screen on them just to see what they're looking at. We had responders. They've all got their little teams on their back. They logistics or command or the finance ladies were having a great time. I think they didn't get to go out in the field very often. They were probably the most organized batch I've ever seen. These guys are looking at ERMA and trying to make decisions about how to deal with the response. We started getting people congregating around some of the screens, trying to figure out how they're going to deal with stuff, where things are located. One thing that I noticed, though, is that when the command team got together to make the final decision, there's not a single computer display, let alone a laptop or even a cell phone here. These guys are all on paper. There's a computer display relative to these guys, about where this is. None of them even looked over there. They've all got their notepads, and then they walked away after they made their decision. And I don't think anybody at the 5 tables around had any idea what happened to that command table. And that's what's controlling the whole what's going on. So it's a little tough. And the basic conclusion that I came away with from SONS is a pretty sobering one. And NOAA calls this a hot wash, where you basically, you're going to go take your laundry and get it clean afterwards. You're going to figure out all the things that weren't quite right. Well, my conclusion was we're not ready. So here's some of the things that I saw. One, faking data is difficult. If you don't have oil in the water, you've got to have a modeler go think about what would happen, and then he's got to go sketch it out when all his tools are used to dealing with real data. So a lot of the techniques are not designed to inject fake data and then go create a scenario that matches something that could be realistic. It's very hard to create realistic data. Location names caused huge amounts of trouble. Someone shouting out a name from across the room, like Scataqua, if you didn't know how to spell it, do you know how to Google it? People confused point and rock and all sorts of different things and mixed them up with their names. We had several cases of people running over with a Post-it, sticking it on a screen, saying, we need to deploy here. Well, nobody could find that spot. It was typoed. Someone had just shouted it out, wrote it down, played the telephone game, called someone else, and by the time it got to the command center, nobody had any idea where it was. There was little or no use of charts or the Coast Pilot. People looked at me funny when I pulled out the Coast Pilot to try and figure out one of those names and finally found it in the Coast Pilot as a pretty horrible misspelling. I didn't see any charts on tables, didn't see charts on computers. They're supposed to be moving ships around harbors. I'm not sure how they mean to accomplish that in these kinds of cases. I asked which vessels are involved. You're doing a test here. You might be moving ships around on paper. You might be moving around for real. I finally saw a newscast on a TV in the corner from some reporter, and I saw a ship. I saw a name off the back, so we started tracking that one. Is a coastie actually working in the project, but people didn't realize he was. And of the ships we did find, very few of them had AIS transceivers on them, so we could track them. We had some serious IT issues up in Portland. Printing. Everybody loves their printouts, but yet they were all spending hours trying to figure out how to get the print drivers to work and all those things that you run into in the daily office. You've got everyone madly trying to figure out how they're going to print when they've got a big computer screen next to them already showing the data right next to the command center. There were so many people bringing in their laptops, the Wi-Fi got overloaded. I was one of the few people who was able to keep going, and I started using ERMA on my own to show people because I had my cell phone hooked up to my laptop. And that was working, but yet all this expensive Wi-Fi gear they had going wasn't working. And this is in a case where we're in a drill where things should be fairly mellow. We don't actually have oil in the water. We don't actually have people hurt. It should be the easy case. Communication, as I said, it was more like rumors and note passing. When I was in high school, I think 2 people had cell phones. It was pretty wild back then. And they're acting like it's before texting. I didn't even see texting going on between people very much. And as a conclusion of that, I realized that our field personnel need a mobile device that's secure that they can send back their reports, where they can type in the name of the location in a way that they're not calling up and having someone else trying to write down what they mean to say. Now that was in March. This happened April 20th. So a month and a few days later, this is the Deepwater Horizon in the Gulf of Mexico. She's actually a ship, even though it's a drilling platform, this is a ship. She caught fire, exploded, 11 people died, really horrible event. I remember hearing about it on a maritime news group and just was like, wait, what happened? I don't understand. Here's what she looked like. This is her sister ship being transported out of being constructed. To give you a sense of what this is, it's a pretty huge device. This is a large ship to start with, carrying an even larger behemoth on top. So we had to scramble. We weren't ready. ERMA was just trying to roll out to both New England and the Caribbean. I was thinking about maybe going other places. So 5 days later, we had something up, and you can see there's not a lot that I've got showing here. We're still working. We've got some categories, and we've got a few things sort of shoved in. We weren't at all ready for this. We were really scrambling. We started getting things like charts in there, basic stuff like that. You start seeing some ships that we limped along in the beginning. My software wasn't ready for ships of this magnitude. I was handling a couple hundred ships, and I didn't know how big the response area was, so I was trying to track 5,000 ships with code that wasn't really optimized for handling that many. But we did get there, and we ended up finally, this is mid-July, with an interface that was actually working for the responders. for those who had access. I know people on the ships didn't always get access to this for those who were trying to look at it from, say, the Pisces. So where does this data come from that we're trying to scramble to get? The key thing is here, by being open, we're taking data from all over the internet and sometimes all over the world and trying to glue it together in a consistent way for these people. The AIS data came through some code that I wrote after the response started, loading up several thousand ships in there. There's a technology called GeoRSS, which is really simple syndication. These are basically like news feeds that tell you location and something happening. We use those for sensors and things like that. KML is the Google Earth format. There's a new addition to it called extended data, which lets you, in addition to making a pretty Google Earth map, it actually brings in machine-readable data with it. GeoJSON is a new technology for sending little bits around the web. It's a very web-oriented protocol. And then there's a critical one here called Web Mapping Service, and I'll show you a little bit about it more. This is super important for things like ERMA and tools that are related to that, being able to share maps really easily across the internet. And we get some really crazy things. I learned about a new technology, well, it's an old technology that I didn't know about, called an SLDMB, which I have no idea what it stands for. It's a little buoy that they throw off of ships or out of back of planes, I guess, for search and rescue. And the Coast Guard was very stressed out that I was being able to see this data, but they wanted the responder to see it. And they're now tracking these buoys all around the Gulf. They throw them in the water. It's got a temperature sensor, and it drifts along and shows you, I guess, current drift. Things like this I'd never heard of before, but suddenly, 5 days after I've heard of it, it's supposed to be up on display, and people are supposed to be using this in the interface. Here's an example of the GeoRSS, being able to use things like Google Maps, and just taking an example file, here's those buoys, and being able to just throw that into Google Maps. And actually, these tools all know about these protocols. So I can take a GeoRSS, put the URL on Google Maps, and I suddenly have my buoys moving around on Google Maps. That kind of freaked out the Coast Guard because they were trying to keep this data really protected, but also get it out to everybody at the same time. So it's a balancing act between getting stuff out and keeping it protected. Behind the scenes are a lot of rooms like this. This one over here on the right is referred to the zombie room by the people who live upstairs from it. These are Coast Guard tracking stations. So these are the AIS receivers, automatic identification system receivers, throughout the country. There's a good number of them down in the Gulf of Mexico. And based on that, this is what the Gulf looks like to me sitting back here. It's a bunch of these little dots crawling around. Ants look like they move a lot faster. And the oil spill actually happened down in this area. And all the white ships are your uncategorized ships. And based on various reports throughout the area, I try to come up with a list of ships that are involved in the response. People will give me, email me these weird copies of fax reports that have been faxed about 5 times. With things I learned what a John boat was, that I actually don't care what a John boat is. It's a small aluminum hulled thing that doesn't have enough space on to really carry any tracking or anything like that. They sent me lists of hundreds of those, and then didn't say whether they were in the Gulf or in the Atlantic or in the Pacific. From that, you had to figure out which of these ships are actually working on oil spill issues. And then we also didn't know when they were leaving the area. So we've got ships over here that may or may not be doing oil spill stuff, but they're still tagged because at one point they were working on oil spill stuff. And here's an example of probably the best document I ever got saying what ships were involved. Some of the stuff I got by watching the news and seeing when they were carrying out the containment dome, I would read the name of the ship off the newscast, go over the computer, try and find the ID number for it, and put it in the database so it would get tracked. The thing is that we have Coast Guard ships in here. Sometimes on these documents they'd say CGC for Coast Guard Cutter, but then when you go look at the ships broadcasting who they were, there would be a Harry out there. This one's the CGC Harry Claiborne. You'd just see Harry. And there'd be 12 different Harrys running around in the Gulf of Mexico. And you'd wonder, which one is the Coast Guard ship? I'm not sure. Very challenging situation. When you get it figured out, you then zoom in and you join the parking lot. I'm sure anyone who's been out there realized that nobody went anywhere very fast in this area. In fact, SOG, I've hit info up here, clicked on the Ocean Veritas, which is a green research ship, and its speed over ground is 0. Most of the ships in here had speed over ground of pretty close to 0 all the time. It basically, from these maps, it looked like a giant tangled mess. Now, one thing that became apparent pretty quickly is that we had a lot of restricted data, and NOAA had a process for allowing who could see it and who couldn't. There was requests from up high, like at the admiral level, saying, I'd really like to see this data go out to the public so anyone can see the responses going on, what ships are out there, and who's involved. And the Coast Guard's response from the Operations Center was, absolutely no way. That's illegal. You can't do it. Over my dead body. Now, we do have precedents. This is the Healy. One of our computers in our building here is getting an email from the Healy every hour. It's sending out a nice science summary of what's going on with the Healy. It's sending it, taking a picture that's stored at Lamont on the web, georeferencing it and putting it on Google Earth, and actually sending it back to Google. So if you go into Google Earth, turn on the ocean expedition layer, fly into where the Healy is, you'll actually see her moving around on the map. Admiral Allen, who was in charge of the whole thing, decided to weigh back in on this whole thing, since he's an admiral, and his answer was, release it right now. And I got the email about 4 hours later, and everybody in the Coast Guard was freaked out because that was 4 hours ago, and he said it must happen immediately. I've never seen people jump so fast. So what happened based on that is GeoPlatform, the public version of ERMA, immediately got live ships. And I think I was sitting next to Val at the AV boot camp, getting phone calls from the Coast Guard saying, we're panicked, we have to have this release live now, please go, when I'd rather be playing with an AV. So this went out on a Friday evening, about 7 p.m., suddenly it was live. And for the Coast Guard, this is a huge deal. This has been considered very sensitive data up until now. These ships are updated every 2 minutes with the official national feed for where ships are. We also got some very unusual requests. There's these little devices that they sell. It's about $100 plus, I think it's $50 a year. You hit the button on here, and it sends a message up to a satellite and tracks you. You can just stick it in your pocket on, and if you're not me in New England, it actually works. I tried to take it around UNH, and it never found me. But down here in the Gulf, closer to the a better view of the sky, these are actually small boats, the NRDA NOAA teams, carrying these devices around. They're being tracked by the Spot company that sells these. The Coast Guard convinced, and NOAA convinced Spot to go ahead and give us a data feed, and then they convinced us to go ahead and put that data feed in ERMA. So if you have a responder account on this thing, you can actually go see where all these boats are around if they've got one of these dropped in. Sometimes it's sitting on the dash, sometimes it's on a person. We also got other weird requests. Most of the Coast Guard people use a cell phone service called Good. It actually tracks where you are every few minutes. And the Coast Guard said, we would like you to track everybody. I said, excuse me? You want me to track what? And I said, well, everybody's running this on their Blackberries and iPhones and whatnot. We want you to track them using Good. And I realized I would then know where Admiral Allen was up to every 15 minutes. And I said, no, that's okay. I don't need to know that. You can figure out some other way to do it because I don't want to know where everyone is. Sometimes information is just too much. And an example of the too much, they want us to track all planes. And they started sending us plane data. And so here's one of the files they sent us. It's over in Florida as a test. And it was just tons of data about planes flying around and no information about is the plane actually doing something relevant to the situation. So a lot of what happens here is data overload and trying to go into these people and work with them to say, can you flag your data somehow as important to responders or not important to responders? It's very challenging. Another example of that is photographs. Someone went and photographed all the coastline and from an aircraft and then didn't tag it in any way. So we have tons of photographs sitting in the database and no way to know which ones are important. You have to go through and guess yourself which are important. Pretty challenging. Now, getting back to that WMS or web mapping service, I want to show something that's happening in our building right here. This is NowCoast. And NowCoast is tracking all sorts of data from all over the government and probably not even stuff in the government. And here is a hurricane coming through. And what NowCoast does is it actually takes the same data as sending out in the web interface for humans and sends it out web mapping service. So we can subscribe to it in ERMA. And the best part is that by being in the same building or on the same campus, we're really able to go over and figure out what those interfaces are and pick out the best data. So that when NowCoast is tracking something that's important, ERMA should be tracking it too. So here's a large storm coming through this way. Thankfully, this one didn't bother the team too much. But Hurricane Bonnie happened during this time and came right up through the middle. Thankfully, it died out before it caused too much trouble, but when you're trying to deal with operations at a site that's got that much sensitivity, trying to have ROVs down many thousands of feet working on very sensitive tasks, a bad sea state is not a good thing. Along with that, we pulled significant wave height. So here you can see you could load in that track, or you can look at significant wave height. Again, we have these strange SLDMB buoys running around tracking things. But this way you can integrate all these data sets and see them either in NowCoast, if you're comfortable with NowCoast, or in ERMA if there's stuff that you need to match up that's there. Here's something from Colin. This is the FlowViz data laid in the back with some transparency, so you can see the ships moving around on top of the currents. I'll get back to this in a bit, but we didn't have a lot in the way of bathymetry. This is a single beam survey from the 80s that NOAA found in the archives and made a nice map of, but we didn't have a great multi-beam survey available to us. And companies like BP may have stuff like that, but they wouldn't give it out. So we didn't have great bathymetry in the area, which is kind of surprising. Before getting to that, one thing that's brand new to ERMA and services here at CCOM is that CCOM is actually watching parts of ERMA and keeping track of it automatically. It's something Jordan and I put together where we have this program called Nagios that's every few minutes going out and pinging a whole bunch of the systems to say, are you okay? And as a part of that, we actually have a graph now of how many ships are seen every 10 minutes. This is these are days across the bottom, and you can see daily cycles of number of ships seen in the network. The nice thing about this is every so often something goes wrong. It usually seems to happen about 10 p.m. on Saturday evening, and it usually involves a call from Admiral Allen to me via one of his captains saying, my favorite ship has disappeared off the map. Where'd it go? It means that somewhere in the network, for example, one time it happened down in West Virginia, they had a network error. We had a dropout for about 6 hours of about half the data. A whole bunch of the ships out of the Gulf of Mexico just disappeared. This way, I get an email before Admiral Allen figures out that the ships are disappearing. Another great thing about this kind of system when you're using open source is you can go and say, hey, based on the public data, would someone be willing to contribute a particular interface? We need some help. We don't have any money, but does someone want to just volunteer out of the goodness of their heart to do something like that? And I had an idea. There's an interface called Simile Timeline, done at MIT, which is a web interface for viewing timelines. And a guy named Jim Myers, I just posted a note saying, anybody want to go for it? I'll talk to you through the process if you want. I don't have time to do it. He went and bought a little web domain, oilspillstats.com, and they put together an interface on the web that anyone can go to. Just type that into your browser. And if you scroll on the bottom, you can either scroll on the hour level, the day level, or the month level, and all the little events that happen throughout the spill response goes streaming by you. So if you have a day that you were interested in looking at what's going on, you can see throughout the day as all the Twitter events happen from all the government agencies, and anything that was publicly available that you could grab, you went and put into this interface, you can scroll through it and watch what happened. If you're going back and doing sort of post-mortem analysis of some aspect, you can then sort of dial into your day and get a sense of what was happening back then. Now, it's a big question. Are we ready for another oil spill as a community? So we've just been through a long event, which is very unusual. Normally, a spill happens, it's a small thing, you clean it up, and you go away. Even with the Exxon Valdez, the primary response was fairly short. The amount of oil was small compared to this one. But we're having this time to sort of work through things. We could go through, come up with an idea, try it on the oil spill, didn't work, try the next one, and see what we could do. My answer to that is probably we're ready right now. But the problem is with time, this knowledge gets lost. A lot of people move on to new jobs. Those who've been through it before retire or move on to a different portion of the company. And those who are in those positions when the next oil spill happens are brand new. And a key aspect of that is everyone's tired. People put in a lot of hours. There's been a lot of 7-day-a-week, 12-hour-a-day events going on for people, and our two folks in charge here are showing it too. Another challenge for us here outside of the oil spill itself, for those who are trying to come up with technologies for this kind of thing, this is the one and only picture I have that shows ERMA in action at a Coast Guard center in the Gulf. There's apparently a ban. Some people told me they've tried to take photos for me, and they've been disallowed from taking out cameras in the operations center. So I have no idea what it looks like or how ERMA is set up in various places throughout the infrastructure. So this is one press release. This was released by the Coast Guard on Flickr. I was just skimming through the pictures, and I'm like, wait, that looks familiar. So that's the one picture I have of ERMA in action in the Coast Guard Center. That's in a mobile command center in Alabama. No, but it's up in the back, which is the idea. If you guys spend too much time with ERMA, it's not working. So where to next? I have a few more minutes, but I just want to give you a sense of what might come for future technologies and how we can do a lot better, because we definitely aren't there for a perfect system. The first one is mobile devices. Things like an iPad. This iPad has a 3G modem in it, so anywhere that you have cell coverage, you can get data to and from it. This is the fire attack group in Sonoma County, so this is wine country. This guy outside of his window looks like grapes. And he's actually moving planes around California for the wildfires. And he sends out these guys. He's an observer, and this is a plane that drops retardant on fires. And they've been working with NASA. I've been joining in on some of their work. And the idea is giving them Android phones where they can actually use them in the field. Here's some other examples of mobile devices in the field. But give them to the first responders so they can interact with their command teams a lot better. I'd like to show you this example. This is actually was going on as we watched in the command center. This guy didn't have time to talk to us because he just got a call. He's just dispatched a pilot in that little observation plane who's trying to get out to the fire as fast as possible. And he's just gotten a message back from this guy. The pilot has actually carried the Android phone with him, held it up to the window, and took a picture as he approaches the fire. And the best part is the phone takes care of the rest. It's georeferenced everything, and he gets back a picture looking out over this lake of the pilot approaching. I think you can just sort of see some hazy stuff in there. That's a big forest fire that's about to get a lot bigger. So he immediately has a sense of what the pilot's seeing out there without the pilot having to spend 5 minutes describing where the fire is, what it's doing, what its state is. The observer out here is supposed to be talking to other planes, not back to the command center. In addition to mobile devices, we want to look at more command and control. This is something that Lee Alexander and I have been struggling through for a couple of years. All these ships carry these AIS transceivers. You can actually send data back out to the ships and have it put on their charts. We're looking for ways to be able to say, where on the water is the oil, where on the water should you be? So basically, instead of having those 15 minutes of calling everybody and saying, okay, you're here, you need to be over there, and the oil's over here, we want it to be right on the chart, automatically electronically done, and the guys working out on the ships are just looking at the chart and glancing at it, and they're off doing their main job, looking out the window and dealing with the oil. The next one is a big CCOM topic. We definitely need better background data sets. That little thumbnail of single beam sonar data for bathymetry, that's not okay. NOAA's been working hard with their survey ships to collect bags, bathymetry attributed grids all around the country. This is some other work I've been doing with Shep Smith to try and track all that work being done by our hydrographic survey fleet. I'm going to zoom into here, but you can see that there's a lot of survey going on, but it's a big ocean. So there's a ton of work going on here, but there's a huge area, of critical stuff full of oil platforms that hasn't been surveyed anytime recently. We zoom in, this data is great, but look, there's a huge gaps. It's too shallow in here. We need some sort of LiDAR coverage probably in this area. And this is the main shipping channel, which is NOAA's primary requirement, but there's no money to go out here with other vessels and survey that. So I believe Larry's working on that issue, trying to push forward on getting a more complete coverage of this whole area, because with so many oil platforms out there, there's just bound to be trouble. We've already had one more explosion since the Deepwater Horizon, thankfully a small one. And the key thing to go with this is that we need continued testing, training, vigilance, and collaboration among everybody to keep those skills that we've won the hard way from going away. From the Ixtaczi, how do we pronounce the Mexican event that happened in 1979, a huge 9-month blowout, and the Exxon Valdez, we pretty much lost 80% of that knowledge about how to deal with these events. And everyone out there is pretty much new and green at this. And we need to keep that from being the case again when it happens again in the future. We want our people to absorb that knowledge from those who went through it now. So thanks for listening. I always like to say we're charting the future, things like that, figuring out where we're going. And if you want to know more, most of the stuff that I can put up on the web, I put up on the web. I've got a blog that talks about some of the stuff a little bit obtusely, depending on what I was allowed to talk about at the time. And the software for everything that I've written for all of ERMA is actually up on the web, and you can download it if you'd like. Thanks. Questions? Tom?
Some piece of this, I'm not saying that was the major piece, but some piece of this was the subsurface oil in the deep ocean.
Mm-hmm.
And you have a very two-dimensional view there.
Yep.
And what is still missing to this day is a good sense of what happened and how to integrate all that data, which has been collected now over the last, well, since May, at least.
Yep.
Any thought of getting current data, glider data, CTD data, all that kind of stuff to help guide that part of the response?
The mid-water column and bottom stuff is definitely important, and some of it's in there. It's fairly restricted, and the problem is that I know people here have been accessing it, but I don't have the permission to translate it from my source to the people who I think should get it. I don't have permission to make that bridge for some of it. The other thing is that this is never going to be a 3D tool, so if you want to look at things like structure in the water column, this web interface is probably not the thing you want to use. It might be the way you want to find the data and just hit download and then go load it to some other tool. That's a perfectly reasonable way to do this kind of thing. But trying to do anything that has a lot of vertical structure to it in a 2D web mapping interface is just not going to work very well.
So that's, any thought about how to get around that? Because guiding that portion of the response was something that was really important to do and never got done.
Yep. I think some of that, like the glider stuff, is in there and tracking where gliders are, but we had a communications problem. So somebody added the data in. It was layer 5012. We have, I think, 8,000 layers right now. There's no mechanism that lets me tell the community who's involved in this that that's what happened. I have one point of contact that I can call up and harass, and then hopefully they can go find people to harass. But in terms of like CCOM, we walking around the halls, you and I talked about things. We kind of had a back channel, but that back channel isn't really authorized. So we did it anyway, but there isn't a way in ERMA, like latest news, new features, this data just came in, this data was just chucked out because of X, Y, or Z. We had several layers that showed up, weren't right, and we had to kill them. Someone may have used that, we don't know. No one ever told me how much it was being used until it broke. And then Saturday night at 10 o'clock, I got the phone call of, we've been loving this tool and it stopped working. Oh, someone's using it, great, that's wonderful. So getting those kinds of things throughout the system, like the ACP data, I knew it was there, I didn't know how to get it, I knew where it was going verbally, but I didn't actually know where that was. So we have a lot of work to do with crossing some of the barriers between organizations like BP and the government. That barrier sometimes is very difficult.
ACPs are on a public website, actually.
Oh, really?
Yeah.
See, I was told that was restricted data.
National Data Buoy Center. For every rig down there that has one, I think they're mandated by law to put it up.
Great. See, that information is hard to find sometimes when you're deep in the middle of something that is really restricted. I actually called up BP.
There was an ocean observatory about 10 miles from the spill site, I found out just like a little while ago.
Really? There's an observatory? Oh my goodness. Yeah, so I actually called up BP at one point, and then got a call from NOAA saying don't talk to BP again directly. So it's tough. I mean, I was just trying to get data from BP to go to the Coast Guard, get to the right person, and the legal issues involved in an oil spill sometimes trump sanity. So I think this is basically just a platform we have to use to jump forward and to find these things and identify them. And sometimes it's going to be lawyers in there who have to go and get over it and figure out a way to undo the problem. Val?
Yeah, I have two comments. One is I think you ought to add to your list of priorities something like the timeline feature, because a lot of the information there is sort of persistent, but a lot of it is really temporal in nature and gets stale after a while. And if you had the ability to scroll through the map and watch everything come and go as it came and went, and then or organize the layers by time in some way,
Yep.
I think that would be really helpful, especially for someone who is just coming into the project and hasn't watched it evolve over time.
Definitely.
The other thing is, and this gets a little bit to Tom's comment, is that I think even if you had a lot of the scientific subsurface data feeds coming in, they would have been really hard to present in a way that people can digest quickly. For example, the subsurface layer monitoring stuff, there's a bunch of CTD casts. You already have the locations of where those casts were, and you could have clicked on those and shown the profile. But it would take hours of going through and looking at all the profiles and looking at the dates to try to get the big flick of what's there. And the real information in that was a couple of points around a particular layer that could have been gridded and shown as a grid, and would have been immediately obvious what was going on. And so I wonder if it makes sense to define a handful of data products that would be good to show for any kind of spill response, and try to get NOAA or whomever to put a processing pipeline in place as part of their spill response that says, okay, we need to produce these kinds of data products. We're going to assign this group of people to do it, and funnel all the raw data in one end and push stuff out to you on the other.
I think those are great ideas. We're thinking about a lot of that. The one biggest factor here is that when you saw those pictures of people working on paper, what people ask for is, I want a printout of ERMA. And then you see people running around with printouts of ERMA with 3 layers on it. And then someone asks them the question, they run back and they make another printout. We have a mentality of the computer is scary to some people, and it can be very scary, and the tools definitely are not good. We also have some institutional barriers, such as NOAA produces a chemical database that the Coast Guard requires. It has a time life before that information expires. The Coast Guard review time for the software from NOAA to be deployed in the Coast Guard environment is longer than the lifetime of the data. So we have some institutional problems where it's a 13-month review process. The data is good for 6 months. So by the time you've validated the data okay to put in the Coast Guard system, you should throw it out. So those kinds of things tend to trump what we'd like to do, where we present all the data in the best way that we can. And so things like FlowViz 2D from Colin circumvent that whole process. You go do something on the research side, and then you kick it in, and magically it just suddenly appears, and people go, whoa, look at this. We need more of that, but we don't always have funding or time to do it.
Some of what you're talking about, some of those, distilling those, thousands of CTD vertical casts to some kind of flat file, and then making an image out of that, that actually happened. That actually happened. Larry actually was the guy who was providing that, and is actually still providing it, using Fleeter mouse, and tried really hard to get other people to use Fleeter mouse, and some people did. But the other thing that happened was eventually, I think, people picked up on the idea that, hey, that's useful information to guide the response, the subsurface response. And they started doing it in a GIS and started doing just what you described. And I think they just stopped maybe a couple of days ago, providing that. Every day they would provide an updated plot of the data for the last few days. But to have it in something like this would be much more powerful, particularly if you added a timeline. And I think they just didn't know. Yeah, and we have a lot of disconnects here. For example, the PDFs that I showed you up until recently, the modelers assumed that the PDF was the only source that people wanted. It says their group, it's vetted, it's got all the things that they think are important, but it's a paper. So someone who's trying to then throw something else with it in their GIS is out of luck. So we need to be able to get everybody to understand what the requirements are and not overload them. There's a lot of people who are working as much as they can, and they just can't do any more to get these things in. The other thing is that up till recently, NOAA has thought about oil spills as the surface and the stuff on the bottom. It's, you're in a river, it's 30 feet deep, it's either on the surface or it's hit the bottom, or within a few hours it hits the bottom. This is a very different case than almost everything they've dealt with before. So the mid-water stuff is really new. Question?
Yeah, almost all of the requests that hit your system are geographic in some way.
Yep.
And I've seen some interesting sort of post-analysis of EMS systems and things like that, where you can just follow how many hits, what areas. You can begin to build statistics on who's using your data and what it's doing. And you might want to think about what that could provide to you during an implementation.
Yep.
You would maybe know more than you wanted to about who and where and what people were querying.
Yep.
And that might give you a way to come back at the system and see how it was used.
That's great. Right now, we've been struggling with just scaling up from 50 users to several million hits a day, like 10 million hits a day.
But you can drive through the Apache logs and actually begin to...
The one trouble here is that a lot of those logs a lot of those hits are going all over the place. It's very distributed. So some of our machines aren't able to keep those logs around. They're just getting so many hits. We're dumping a lot of stuff that we'd like to keep. And we're pulling WMSs from all over the place, and we don't have time to figure out which is the active ones and when they get what turns into what else. So we have a layer.
Yeah, it does have that sort of spider character to it, but
Yep.
you might be able to just have something distilling those logs in real time.
That would be wonderful. Yep. Is there a question in the back, Colin?
You touched on a really important issue, and I think a very, very difficult one. I just wanted to hear more of your opinion, which is how do you preserve it? You can build a sort of, you could spend unlimited amount of money. You could have a team of 20, 30 people building the perfect ERMA, for years, and then it only gets exercised, besides which nobody would fund that. I mean, should it be CCOM that maintains? Should it be NOAA? Should it be the private sector? I don't know. Or how does something that you put together and started to learn how to do things right, learn a lot of lessons, how do you preserve all of that?
Preserving is definitely a big challenge. The commercial model has failed so far. So every company wants to preserve all the profits for themselves.
Oh yeah, you give it to Raytheon and you'll give them $10 million
and we'll end up with
$10 million every year forever.
Yeah, and we'll end up with PAWS is a really, really great idea. It's the waterway management software for the Coast Guard for VTSs. It's really great, but any change to it is on the order of $15,000 or $20,000 to change some text on it, and it's all buried in there in the contractor's world, all the knowledge. We've tried to push some of that knowledge into the open source world, so that knowledge is public. We're using technologies that are already out there. We're interacting with the community, trying to save it that way. But we're also reusing these technologies for other things. So ERMA actually came out of a small bird flu project and another project where emails were coming from Asia to a UNH server and going into a device that was building up a map server device and view just like you saw up there, but for ducks flying around Asia with bands on them. So if you keep reusing the technology and you keep mixing it up, then you start learning how to make these systems scale, how to use them for different devices, and keep that churn going. So what we view ERMA as down the road is you may junk everything that you see here, but you've learned a ton of lessons and you can remix those components for your specific instance. For example, you might be building a system that's just focusing on a very small harbor. You don't have the Gulf of Mexico to worry about. You might pull some of those pieces and not need to create a system that can handle the entire U.S. population attacking it to find out what's going on. You might just have the harbor master and the local 1,000 people who are voters there being using the system. And it's that remixing that might help. Chris?
Having all those source code open, how many people are actively contributing? Is it a few or dozens?
The core, jump back to that first slide. The core software contributors is about half those people are software contributors. But what we're getting is when someone fixes the Postgres database to add a new feature, for example, we had to hack our own replication of getting data from one site to another that wasn't as complicated as some of the ones that were out there. The new version of Postgres has that built in. So in a lot of ways, we think of those people as working for ERMA too. So it's got, Aaron has probably written the most recently. The CRC folks funds some folks over in Morse Hall who've written a lot of glue code to keep this stuff going. So there's maybe 5 or 10 core folks, and then we have one guy whose sole job is printing. And I think the poor guy is getting clobbered because printing is a pain in the butt. But then we really leverage a lot of people. So we go back to a community and say, map server isn't doing this, that, or the other thing, and we submit a bug patch, a bug in like a preliminary patch or some concept, and then it trickles back to us over time. So we're trying to have a few point people and then take advantage of that distributed community. I mean, if you look at Boost, it's a C++ library. On their front webpage, they have an estimated number of man hours they've gone into it and an estimated dollar figure. And I think they're at an investment level of like $250 million estimated investment in just one library. Any more questions?
Well, thank you.